To most of us, this is just dirt. But its value, not just to farmers, is vital.
It's vital to all of us because the soil contains a little world or ecosystem of living and non-living things. These components constantly interact to allow the soil to produce many of our needs, such as food, fibre and timber. Under natural conditions, nature achieves relative stability between the climate, the land, plants and animals. When changes do occur, they're usually slight and gradual, and the stability is maintained. Early Australian pioneers looked on their new environment as a challenge, to be moulded to their more European ideal. In many cases, the introduction of agriculture caused sudden, sometimes dramatic changes. Trees were removed, the soil ploughed, and the pastures were intensively grazed. This effectively created new ecosystems. Because these were not always in balance, in many cases, there has been a rundown in the ability of our soils to meet our needs. Loss of nutrients, breakdown in soil structure, outbreaks of weeds, even salinity and soil erosion are obvious signs of this degradation.
This is not a pretty picture. But it's not the inevitable result of agricultural activities.
A new balance can and is being achieved, which allows agricultural production to be sustained in the long term while maintaining a healthy and pleasant environment. This can be achieved by understanding soil-ecosystem relationships. The 6 vital parts of this ecosystem are the mineral parts of the soil: sand, silt and clay, the water in the soil, soil organisms such as worms, insects, fungi and bacteria, nutrients that are needed for plant growth, weed control in agriculture, and soil protection through ground cover. It's the relationships between all these parts that we have to understand. To show these interactions, let us start by looking at the fate of water falling from the sky as rain and entering the soil. The fate of each of these raindrops is important to us. When raindrops hit trees, pastures, crops, dead plants and leaves, or any other form of ground cover, they lose their force on impact and filter gently down to the soil below. The raindrops that gain entry into the soil because of the vegetation or stubble cover move slowly down large pores or cavities called macropores. This moisture is then stored in the smaller micropores, a bit like a sponge. Because soils are composed of different amounts of sand, silt, clay and organic matter, they differ in their ability to absorb and store water. Even the seemingly unprofitable work of the common ant has its place in the interrelation of soil water and the soil. Channels formed by ants, decayed roots, termites, earthworms and other soil organisms are valuable in providing easy entry for water. Once in the soil, in and around the PEDs, the soil water becomes very involved in the chemical reactions that take place in it. Plants require many different nutrients or natural chemicals to grow well. Many of these are required in large quantities, some in very small amounts. Some come from minerals naturally in the soil, others from the breakdown of organic matter by soil organisms. Another source of nutrients is the addition of artificial fertilizers. Nutrients in the form of ions move from clay particles and organic matter into the soil water. When they make contact with root hairs of plants, they're drawn up to other parts of the plant. Water takes part in many chemical reactions in the plant. One of these is photosynthesis, the production of oxygen and sugars using sunlight and carbon dioxide as well as water. If the water is not involved in chemical reactions, it will evaporate through the leaves and return to the atmosphere.
That's the good story. Rainfall absorbed completely into the soil to assist nutrients to produce a healthy plant. But the life-giving soil-water cycle doesn't always flow as easily as that. Let's take a look at what can go wrong.
Where there is no ground cover, the drops pound into the ground, smashing soil crumbs called PEDs. This breaks off tiny particles of soil which gradually clog up the soil pores, the vital pathways for water to reach the root zone, where it's needed for plant growth. The water blocked from entry builds up and then runs off the surface. As the rain continues to fall, the water flow or runoff becomes deeper and faster, gouging out soil from the surface, creating small channels called rills and ultimately larger ones called gullies. The runoff also carries silt and chemicals to other parts of the landscape, where they may cause pollution. Water entry can be improved and runoff control achieved by keeping ground covered with crops and stubble, and by slowing down runoff water using contour banks. Even when water enters the soil, a compacted layer can sometimes prevent the water from moving further down the soil profile. Above this layer, waterlogging occurs. This prevents plant roots from getting oxygen and plants soon die. On the other hand, where water is able to filter into the soil, but there are no plants to make full use of it, the excess water moves down the slope to flatter areas. This can cause water tables to rise and bring salts to the surface. Even water that is stored in the soil under good growing conditions can be wasted by useless weeds. Weed control to prevent competition for water can be achieved in several ways, including crop rotation, tillage, and herbicides.
But the choices are not straightforward. Managing weeds by crop rotation and similar practices require good planning and careful management, and are not always the complete answer.
Herbicides can be costly, need to be applied correctly if they're to work, and may cause unwanted damage to other living things. Tillage is often the cheapest and most direct option, but excess tillage can damage the soil structure and remove the protective soil cover of growing plants or stubble. So, raindrops are effective in keeping the ecosystem functioning, provided the water can enter the soil rather than running off it. Once in the soil, it's used to keep soil organisms multiplying and plants growing. Soil without enough water, nutrients, and organisms cannot sustain plant growth. Before we manage the soil and plants in any way, we should look at the possible interactions, the benefits, and the possible harmful effects of our planned actions.
Whenever we plan to grow plants, prepare ground to receive rain, turn on an irrigation line, or even start the sprinkler on your own garden, we should learn to understand the interaction between the water going into the soil properties, nutrition, organisms, weed control, and soil protection.
If we all understand soil ecosystem relationships and apply them when managing our land, its productivity will be retained indefinitely for future uses.